Good morning, students. So welcome back. So last time we have studied what is a triangle and what are its elements, right? 6 elements rather to be exact. Then we have studied the types of triangles based on sides and angles, right? Now today we are going to study some of the properties of the triangle. So first from that, median. Okay. So what is a median? Now dear students, last year you might have studied the paper folding method for drawing the perpendicular bisector of a segment. I believe you remember that. Now same paper folding method I am going to use. So suppose this is the triangle, right? Now I am going to draw the perpendicular bisector of this. What is a perpendicular bisector? A line which divides the segment into 2 equal parts, right? So that is called as the perpendicular bisector. Okay, now here I am folding this triangle along this side, okay, and these 2 vertices, they will meet here exactly, and then stress this. Okay, so what happens? You can see a line. Can you see? Yes, this line. Okay, so this is the midpoint of this particular side. Now what you do? Join this midpoint to the vertex of the triangle. So that line segment is called as the median. So what is a median? A line segment which joins the vertex of a triangle to the midpoint of its opposite side is called as the median. What is a median? A line segment which joins the vertex of a triangle to the midpoint of its opposite side is called as the median. Okay, so you can see here I have drawn this line segment. So this is the median, this is the midpoint, and this is the vertex. So when they are joined by line segment, that line segment is called as the median. Okay, now I hope you will write down this definition. I am writing on the board also. What is a median? A line segment that joins the vertex of a triangle to the midpoint of its opposite side is called a median. Okay, so I hope you will write down this definition. So how many medians a triangle can have? How many vertices are there? 3 vertices. How many sides opposite to that vertices are there? 3. So how many medians I can draw? 3. But we are going to study to draw medians. They are rough sketches, no doubt about it, for acute angle triangle, right angle triangle, and obtuse angle triangle. And let us see what happens. Okay, so first I am drawing the acute angle triangle. Okay, so this is the acute angle triangle, and I am drawing now median of it. All the 3 medians. You will come to know how many medians are there. So somewhere here the midpoint is. Now these are approximate. So I am joining here to this particular opposite vertex. Okay. Now this is second median. Okay, and this is the third median. So for acute angle triangle, acute angle triangle, the three medians, the point of intersection of three medians, where it is, yes, in the interior of three medians, lie in the interior of triangle. In other words, all the three medians, they are inside, in the interior of the triangle. Okay, now this point of intersection is called as the centroid. These medians are concurrent. Concurrent means, that is, the lines which, or the line segments which intersect each other in one and only one point. So they are called as the concurrent lines. Okay, so here these are, medians are concurrent, and the point of concurrence is called as the centroid. Now this is not in your book, but you should know this. And this centroid divides the median in the ratio 2:1. So this will be 2, this will be 1. That is what the ratio is. So I am writing here, I hope you will take down it. Okay, so medians are concurrent, and the point of concurrence is called centroid. Centroid divides the median in ratio 2:1. Okay, so there are three medians, and medians are concurrent, and the point of concurrence is called a centroid, and centroid divides the medians in the ratio 2:1. One more thing, all the medians, they lie in the interior of acute angle triangle. Okay, now second one. Yes, second one, this is a right angle triangle. Now let us see the medians of this. Okay, so this is the vertex and this is the opposite side. So let us find out the midpoint of this. Approximate, no doubt about it. Okay, do you get it? Then this is the vertex, this is the opposite side, so midpoint of it. Okay, and then this is the vertex, this is the opposite side, so here somewhere midpoint. Okay, so this is the centroid, and so where you get all the medians, their medians lie in the interior of a right angle triangle. Okay, and again they are concurrent. They are concurrent, no doubt about it, for each and every triangle. Okay, so here we will say for right angle triangle, all the medians lie in the interior of triangle. That means centroid is also in the interior of triangle. That is, centroid, or the point of intersection, that what we call centroid, also is in the interior. If all the medians are in the interior, then definitely the centroid is also in the interior of the triangle. Okay, now, so this is for right angle triangle. Now let us see obtuse angle triangle. Now, this is which type of triangle? Yes, exactly, it is obtuse angle triangle. Now let us see for obtuse angle triangle where the medians they lie. Do all the medians they lie in the interior of the triangle, or they lie some of them they lie in the exterior of the triangle. That means point of centroid, that is centroid, point of intersection, does it lie in the interior or exterior of the triangle? Okay, so let us see. Let us draw the midpoints. Okay, medians. First we will get the midpoint. Suppose it is here. This is the vertex and this is the opposite side. Okay, now this is the vertex and this is the opposite side. So midpoint is suppose here. Okay, now so right, and this is the side and this is the side vertex. So this is the midpoint. What happens? What do you get? Yes, exactly. It lies in the interior of the triangle. Okay, so for obtuse angle triangle also, for obtuse angle triangle, all the three medians lie in the interior of triangle. So therefore, that is the centroid lies in the interior of triangle. Now, that is not necessary to mention that centroid divides the median in the ratio 2:1. Okay, that is fixed. What type of triangle you are drawing, it doesn't matter. Okay, so now think, discuss and write. So how many medians can a triangle have? I think I have given the answer. A triangle can have 3 medians. Okay, a triangle can have 3 medians. Draw a median. Does a median lie wholly in the interior of the triangle? If you think that this is not the true, draw a figure to show such a case. Now this is true. We have drawn all the 3 triangles, 3 types of triangles: acute angle triangle, obtuse angle triangle and right angle triangle. Where did the median lie? They lie in the interior of the triangle. So answer here, yes, medians, they lie wholly in the interior of the triangle. Okay, whether it is a right angle triangle, obtuse angle triangle or acute angle triangle. You can draw the figures to show it. Okay, so I have already drawn the figures. I believe you will write the answers to these questions. Okay, now next part after these medians is altitudes of a triangle. Okay, now what are altitudes of a triangle? Let us see. Okay, now this is the triangle. Suppose if I keep it on the flat surface. So height of the triangle, what it will be from this base? It will be from this vertex to this particular side, that is the base of the triangle. Now this is, suppose if I say that this is the base of the triangle. Okay, and if I want to measure what is the height of the triangle, what I will do, I will measure from this base to this vertex. Now there can be infinite lines now from this base throughout this, from here till here I can draw infinite lines. Then which can be the height of the triangle? Okay, I can show it on the figure on the board. Okay, so I have drawn a triangle here. Let us see. So you can draw infinite lines like this. Am I right? So which can be the height of the triangle? Okay. So the line segment which is perpendicular, the line segment drawn from the vertex and which is perpendicular to the base of the triangle is called as the height of the triangle, or it is also called as altitude of the triangle. Do you get it? What it is? It is also called as the height of the triangle or altitude of the triangle. No doubt you can draw infinite lines. From that only one line, that is segment, is the height of the triangle. And that is which the line segment drawn from the vertex of the triangle perpendicular to the opposite side is called as the altitude of the triangle. Okay, so definition. A line segment drawn from the vertex of a triangle perpendicular to the opposite side is called the altitude of the triangle, or it is also called as height of the triangle. Now, how many altitudes I can draw? Definitely, there are 3 vertices, so I can draw 3 altitudes. Do you get it? Now, let us see for different types of triangles where these altitudes they lie. So, first we will see on the basis of the angles. Okay, so let us go for that. So on the basis of the angles, this is acute angle triangle. Exactly, there you are. Now we are going to draw altitudes of this. Let us see where all the 3 altitudes they lie. Okay, so first I am drawing the altitude here. Now these are approximate, no doubt about it. You can use the set square, exact, okay, to get exact altitude. It should look perpendicular. Do you get it? Okay, so this is first altitude. Now, second. Okay, this is second. And the third. We show 90 degree in this way. What it shows that all the 3 altitudes they lie inside the triangle or in the interior of the triangle, and they are concurrent. You can see they meet each other or they intersect each other at one point. And this point of concurrence is called as orthocenter. What it is called? Orthocenter. Okay, remember that. Okay, so orthocenter for acute angle triangle lies in the interior of the triangle. Okay, so let us write here for acute angle triangle. First, all the 3 altitudes are concurrent, right? Point of concurrence and the point of concurrence is called orthocenter. Okay, then all the 3 altitudes they lie in the interior of the triangle for acute angle triangle. For acute angle triangle, all the 3 altitudes lie in the interior of triangle. Actually, we are supposed to tell about the orthocenter only. The point of concurrence lies in the interior of the triangle. That it means that all the three altitudes, they are in the interior of the triangle. Okay, now let us go for right angle triangle. So this is a right angle triangle. Okay, here it is 90 degree. Right? Now first we will draw the altitude of this side. Okay, so this is the vertex. So let us draw that. Okay, so this is 90 degree. Now, where will be the altitude of this vertex? So, if I draw a 90 degree, it comes out to be this. And where will be the altitude from this vertex on this side? So, it comes here. So, for right angle triangle, where is the point of concurrence? It is on the triangle, at the vertex where right angle is formed. Okay, it is on the triangle at the vertex where right angle is formed. This is the point of concurrence. This is the orthocenter. Okay, and so no doubt these are the two sides which form the altitude. So this is only for right angle triangle. Okay, so in case of right angle triangle, orthocenter is the vertex which forms the right angle of the triangle. Okay. Secondly, here the two sides which form the right angle are the altitudes of the triangle. So which are they? These are the two sides which form the right angle. So they are the altitudes. Okay, and this is the third altitude. This is the third altitude. These two are already altitudes. Okay, and this is the third altitude. And where they meet at the vertex where right angle is formed. So this is the right angle of the triangle. So where right angle is formed, at that particular point, these three altitudes, they meet. So point of concurrence for them is at the vertex of the right angle triangle. Do you get it? So orthocenter lies at the vertex of the triangle where right angle is formed. Okay. Now, next is, yes, exactly, obtuse angle triangle. Let us see. Now this is, yes, obtuse angle triangle. Now let us see the altitudes of the obtuse angle triangle. Okay. Now for this is the vertex. For this side, this is the vertex. So altitude. Let us draw the altitude, which makes the 90 degree angle. Right? So this is the altitude. Okay. Now for this side, this is the vertex. So if I am going to draw the altitude, it is going to come in like this. So what it means, I have to extend this. So let us first extend that. See here, now what happens? Do you get it? So I have extended this side for obtuse angle. And now I am going to draw the altitude. So here it is 90 degree. So where it lies? Yes, in the exterior of the triangle, right? And now, for this side, we are supposed to draw the altitude. Now, this is the vertex. Now, if I draw it, it will come somewhere here. Okay. So, what can we do? We can extend this side. So, let us extend it. With dotted lines, we are supposed to show with dotted lines the extended side. Okay. Now, this is going to be 90 degree, right? So it is here. Okay. So here it makes the 90 degree. Now you can see two altitudes are outside the triangle and one is inside. So are they not concurrent? They are. So how they are concurrent? See how. So I am going to extend this, I am going to extend this, and I am going to extend this. See what happens. So first I will extend this. Again with dotted line so that it will help us to identify them easily. Okay. I am using the scale. I hope you are seeing this. You are able to see this. Okay. Now, so this I have extended. Now I am extending this with dotted lines. Okay. Then extend this. You can see where the three lines meet each other in the exterior of the triangle. So where is the orthocenter? In the exterior of the obtuse angle triangle. So altitudes are concurrent, but they meet each other in the exterior of the triangle. That is, the orthocenter lies in the exterior of the obtuse angle triangle. Okay, so here we can see for obtuse angle triangle, orthocenter lies in the exterior of the triangle. Okay, that means two of the altitudes, they are in the exterior of the triangle and one is in the interior. Okay, and when you extend them, they meet each other in the exterior of the triangle. Okay, so dear students, we will stop here today. In the next part, in the next topic, we will continue with altitudes, and there we will see for isosceles triangle and equilateral triangle and scalene triangle how altitudes are formed. Okay, and what speciality there we find. Okay, so let us stop here. Now your homework is page number 114, think, discuss and write. Both the questions I have discussed, and page number 115, think, discuss and write question 1, 2 and 3 and 4. Question 1, 2, 3, 4. Solve them as homework. Okay. So I hope whatever I have taught you have understood. If there is any difficulty, you will definitely call me. And so goodbye till then. Thank you.